Okay, so in this video, we're going to talk about the Cournot model, the Cournot Oligopoly model. Now, Cournot in the 1830, he's a guy who in 1838 explained how oligopoly firms, remember how we defined oligopoly, there's a few firms that hold the majority in the market. Okay, how they behave if they choose simultaneously, so at the same time they're making that decision on how much to produce, so they're choosing Q at the same time. Okay, so two very important things, remember from our previous assumptions. They're choosing quantity, not price, and they're doing this at the same time. Cournot also is the equilibrium that we're going to calculate here is similar to a Nash equilibrium, which means that these two firms are best responding to each other. In other words, they figure out the Q for their firm that maximizes my profit for any or at any level of Q that chosen the competitor chooses. So if I have an equation chooses. So for instance, if I have an equation, my best response for me, Q me, let me write this better. So my best response for me will be a function of whatever quantity they choose. So it could be that if they choose whatever quantity Q them, I will always make 20 times that. This could be my best response. So that means that Q me, my best response, my profit maximizing Q is always going to be 20 times whatever they produce, right? Okay, so if them produces, or if they produce 20 units, then I should produce, to maximize my profits, 20 times 20 units. So 400 units. Okay, so that's the idea here for the Nash equilibrium, Cournot Nash equilibrium. Okay, they're choosing the quantity at the same time, and they're choosing quantity, and they're choosing it at the same time. Now, because we'll say more when we get to the example part, but that's a quick intro. Another thing to note here is that holding other firms' quantities constant, no firm can obtain a higher profit by choosing a different quantity. This is another way of defining this right here is a definition of a best response or an equilibrium. In fact, this is a definition of a Nash equilibrium. Okay, so let's go ahead and do the example with numbers. Remember that we're working with a duopoly in this example. So two firms. Okay, so let's assume that the two firms in our example, our Cournot duopoly example, are American Airlines, and United Airlines. Okay, we're going to call American Airlines AA, and we're going to call United Airlines UA. That will just make it easier for us to follow in the upcoming calculations. Okay, so we have American Airlines, we have United Airlines, and we have that these two firms, AA and UA, compete for customers on flights between Chicago and LA. Okay, so between ORD and LAX, we have this competition between American and United. Now, certain things we need to note to make sure that we are really dealing with a duopoly. First things first, no other company can enter the market because, they cannot obtain the landing rights to either of those airports or to both airports. Obtain landing rights to both airports, right? So to fly between LAX and ORD or Chicago, they need to be able to land in both airports, and only United can go from Chicago to LA. Same for American and back. So it's possible for, let's say, Delta to be able to go from Chicago to Atlanta, ATL, right? They can go this way or back this way, but they cannot travel to LAX. Sure. So we have a true duopoly in this market. Okay, what else do we know? Well, because it's a duopoly, the total number of, let's make this a little bigger, the total number of passengers flown by these two firms is the market. So, and the sum, let me complete that thought, of QA, which is the quantity from American, and QU. So this is people that fly with American Airlines. So I think we said we're going to call that AA. Fly with AA. And these are people that fly with United Airlines. So if we're writing this out, we would have that big Q of the flights between Chicago and LA will be equal to Q from American plus Q from United, right? Because they have only two options, either go with American or go with United as a passenger trying to go between Chicago and LA. Okay, let's continue. Now I want to answer the question, how many passengers does each airline choose to carry? To do this, we need to figure out the point of stability between these two firms. So we need to figure out the Cournot-Nash equilibrium. Let's talk about the process. So to calculate the Cournot-Nash equilibrium, we need to first of all determine each firm's, so steps 1, determine each firm's, I usually like to write what I say, but I'm going to stick to writing certain key or important parts of the sentence. Bear with me. All right, so we need to determine each firm's best response function. Right, best response function, and if you watched earlier, you know what this is for, and this is for any possible output level. Remember when we did the me and the them? Okay. For any possible output level. Now, once we have that, we're going to use this best response function. Let's call this BR. So instead of using the numbers, I'll just write BR and use the best response functions to solve for their equilibrium. Okay. More specifically, we're going to go from total demand curve to get the residual demand curve, whatever residual demand curve. So whatever I produce and versus what they produce, whatever American produces versus what United produces. And with the residual demand curve, we can figure out each firm's, so this would be for each firm. And with that, we can figure out each firm's best response function. And with these functions, we can get the Cournot equilibrium. Okay, that's the process. Now, what we're going to do in the next video here is walk through these steps. Okay.